In this chapter, we are going to find the exact trigonometric values of the angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Using the isosceles right angles triangle, we find the trigonometric values for 45 degrees, and using the equilateral triangle, we find the trigonometric values for 30 degrees and 60 degrees. Study this on your own. To find the trigonometric values for an angle of 0 degrees, we look at this triangle, and here we look at this angle theta, which is already very small. We now keep the adjacent here fixed and make this angle theta smaller and smaller. This means the triangle becomes something like this and less and less. So the adjacent stays as it is, however the opposite in the end will be just 0. And the hypotenuse in the end will be the same length as the adjacent. So in the end, when theta is 0, we have the opposite, which is 0 divided by the hypotenuse, which doesn't matter because 0 divided by something is 0. For the cosine, we have to look at adjacent divided by hypotenuse. We said that the hypotenuse is actually the same length as the adjacent, so we get 1. And for the tangent, we get opposite divided by adjacent, opposite being 0 here, so 0 divided by something is 0. So we found that the sine of 0 is 0, the cosine of 0 degrees is 1, and the tangent of 0 degrees is 0. Let us use the same triangle to look at the trigonometric values of 90 degrees, and to that goal we look now at this angle, let's call it alpha. And again we let this here go towards this side down, so the angle theta becomes smaller and smaller here, which means the angle alpha here becomes larger and larger until in the end it will be 90 degrees. This side here, the adjacent of the angle alpha, will become in the end 0, and the hypotenuse will have the same length as the opposite. So since sine of alpha is opposite divided by hypotenuse, so we get a quotient of 1. For cosine of alpha, we have adjacent divided by hypotenuse. The adjacent here becomes 0, so the whole thing becomes 0. And for the tangent, we have opposite here, something constant, divided by the adjacent. The adjacent becomes 0. Well, we are not allowed to divide by 0, but if we divide by a very small number, what happens? Let us say the opposite has length 1, and then the adjacent has only length 1/10, so 1 divided by 1/10 is 10. If the adjacent has length only 1/100th, then 1 divided by 100 is 100. Or if it has the length only 1/1,000,000th, the quotient that we get, 1 divided by 1/1,000,000th, will be a million. So we see it becomes larger and larger, and it goes off until infinity. This table here provides now an overview over the trigonometric values of these 5 angles. And note here, for the sine of theta, I have rewritten it in a special way, and that's a way how one can remember these values. So we have the angle 0 degrees, 30 degrees, 45 degrees, 60 and 90 degrees. And the sine of it of 0 degrees is square root of 0 divided by 2. For 30 degrees we have square root of 1 divided by 2. For 45 degrees, square root of 2 divided by 2. For 60 degrees, square root of 3 divided by 2. And for 90 degrees, square root of 4 divided by 2. On the left side here you see the actual values, so I have just rewritten these values in a way that we can better remember them. In the last chapter we saw that cosine of an angle corresponds to the sine of 90 degrees minus the angle. And so obviously the cosine of 0 degrees is the same like the sine of 90 degrees. And the cosine of 30 degrees is the same like the sine of 60 degrees, and so on. So the cosine is exactly the opposite way round of the sine. And the last column of the table gives an overview over the values of the tangent.